In this study, we will examine the secondary succession of the forest at Point Pleasant Park following Hurricane Juan from 2004 to 2025.
After a devastating Category 2 hurricane wrecked our own Point Pleasant Park, it lost up to 70% of its mature trees. However unfortunate this situation is, it also provides us a unique opportunity. It gave Dalhousie students the ability to conduct a long-term longitudinal study of secondary succession in our own backyard with a mixed woods Acadian forest. Specific geological and topographical characteristics like the park's shallow roots and wide rock faces made this hurricane especially devastating to the old growth, and it turned most of the forest into a blank slate for new species to start anew. Because of the situation we were given, we could explore all manners of forest ecology to devise models to know and predict future trends in our forests. We specifically wanted to test how different species would interact given fresh resources and a new space for succession. These results provided context in how we can think of these forests and could foreseeably be used to aid in regrowth efforts in the future with forests like these ones. Now, we had looked into this park over other forests in the area because it provided us better logistics for our experiment. But it also has a recreational impact on the Haligonian people and deep religious importance to the Mi'kmaq.
Our objective is to understand how the forest is recovering from the disturbances caused by Hurricane Juan in 2003. We aim to assess how the overall tree community within Point Pleasant Park has changed over time from 2004 to 2025. We want to examine how these changes reflect the forest's progression towards a more mature and stable ecosystem. Following Hurricane Juan in 2003, there were 6 permanent study sites that were established in the most heavily disturbed areas of Point Pleasant Park in order to monitor the forest recovery over time. Each site was 20 by 20 meters, and from the years 2004 to 2025, students were surveying all the living trees that were greater than 2.5 centimeters in diameter. The diameter was measured at breast height, which is a standard of 2.5 feet, and these measurements were taken using a diameter tape. From this data, we were able to calculate several community metrics, including the Shannon Diversity Index and species richness. Additionally, students kept track of tree identifications. To assess the changes over time, we use linear regression analyses in order to show the relationship between our dependent variables and our independent variable of time. Additionally, we evaluated the R-square values to measure the strength of the relationships and use a significant threshold of a p-value that was less than 0.05. To answer our first research question of how the overall forest community changed over time, I looked at whether the Shannon Diversity Index changed in the forest plots between 2004 and 2025. The null hypothesis states that there's no linear relationship between the year and the Shannon Diversity Index. In other words, any changes that we see over time would just be due to random variation. The alternative hypothesis states that there's a significant linear relationship between the year and Shannon Diversity Index, meaning that diversity has increased as time went on. To visualize how Point Pleasant Park forest communities changed over time, we examined the Shannon Diversity Index of consistent plots between 2004 and 2025. Shannon Diversity Index increased over time, which is shown by the slope of the regression line. In the early years of succession, particularly in between the years 2004 and 2009, the values were generally lower and more variable around the line. Some plots even showed very low diversity values during the first initial sampling years. After approximately the increasing Shannon diversity shows that the forest community has been becoming more complex over time. Because Shannon diversity represents both species richness and evenness, this upward trend suggests that more species have been able to establish in the plot areas and that the community is becoming more balanced overall. The lower diversity from the early years is consistent with the aftermath of the hurricane, which would have removed vegetation, disturbed soils, and temporarily shifted the overall structure of the forest. As the forest began to recover, new species were able to reestablish, layers of vegetation returned, and diversity was able to increase, which are all expected patterns of secondary succession. As succession progresses, more ecological niches are able to open up and get filled by species that have various strategies, which can further increase the complexity of the community. Looking ahead, the diversity may continue to rise, but will eventually stabilize as the forest approaches its climax community, where different shade tolerance and competitive species dominate the system and are able to reach a more stable equilibrium between all of the vegetation. Overall, the trend suggests that the Point Pleasant Park forest is steadily developing into a more mature and resilient ecosystem.
Our research question number 2 was, how has the density of the dominant species in 2004, as well as the dominant species in 2025, changed over time? We decided to attack this problem by using the null hypothesis of there has been no significant change in density of the dominant species, or what is the dominant species over the previous 21 years. In order to be able to first, one, identify if there is a change, right? We're looking for a large significant change, or to see if there has been any change in species to begin with. Be able to quantify a difference in density of our first dominant species, being red spruce, we use a linear regression analysis. We use this to examine both how much the density had changed, but also was it a statistically significant one. Our results showed us that over the 21 years that we were recording for, we saw a positive linear increase of our density, and it certainly was significant. It was not a matter of luck or chance. Much is in the same way for our red spruce analysis, we also analyze the density of our red maple. This is because, as of 2025, with the current data, it is currently the most dense and most populous of our species that we saw in Point Pleasant Park. We also saw a general rise and increase over these 21 years. However, it was more drastic than that of our red spruce. In context, the difference between a red maple and a red spruce. Over the last 21 years, red maple has had an increasing density 6.45 times that of red spruce. This is due to red maple being a much better early successor and having the ability to grow quicker, unlike red spruce, which is a later, slower growing sort of tree. Now, when red maple was given the clean slate sort of environment, it was able to flourish and grow quicker. That doesn't necessarily mean, however, that this will be permanent. Over time, we're likely to see red spruce starting to catch up, maybe less so in density, but also in pure tree volume, as they focus on having wider, thicker trees and having a lot of them, which die more quickly.
For our third research question, we are examining how species richness in Point Pleasant Park has changed from 2004 to 2005 following Hurricane Juan. This was assessed by calculating species richness for each site and completing a regression analysis. Our null hypothesis states that there is no significant difference in species richness in the years following the hurricane. Our alternative hypothesis states that species richness increased in the years following the hurricane. Figure 6 shows an overall increase in species richness from 2004 to 2025, with an average rate of increase of 0.4823% per year as described by our regression model. Our regression analysis indicates that there is a moderate positive correlation between species richness and time following the hurricane, as indicated by a R-squared value of 0.577. The overall species richness of Point Pleasant Park increases following the hurricane. This is an indicator that ecological succession is occurring as more and more species start to recolonize the disturbed areas. During the first years from 2004 to 2018, we can see a sharp increase in species richness, reaching a peak in 2018. This is consistent with the trend in species richness during early to mid-succession, due to a significant increase in resource availability and low levels of density-dependent competition. After 2018, species richness begins to decrease slightly and stabilizes around 2022. This may indicate the start of mid to late succession, which is characterized by reduced species richness due to competitive exclusion. We expect species richness to continue to stabilize as the forest moves towards its climax community. Based on our results, we believe that Point Pleasant Park is currently in the mid to late succession stage. This is indicated by both species richness and the Shannon Diversity Index, as they have both reached their peak and have begun to decrease and stabilize. We believe that they will continue to stabilize as we reach the climax. However, by examining the density of dominant species, we see that red maple, which is considered an early to mid-successional species, remains at significantly higher density than the red spruce, which is considered a late successional species. Because of this, we believe that the forest is approaching but has not yet reached late succession. When dealing with urban parks such as Point Pleasant Park, it's important to consider the effects of human activity on the park. Urban parks tend to experience heavy trampling, while moderate trampling can be beneficial. Prolonged trampling is usually harmful. It compacts the soil, reduces its water holding capacity and permeability, limits nutrient availability, disrupts microbial communities, ultimately impairing plant growth. It is important to approach a project using the Mi'kmaq principle of two-eyed seeing, recognizing that both indigenous knowledge and Western knowledge can improve and strengthen our approach to the world.
We would like to thank Dr. Allison Schmidt for her experimental design and the previous BIOL2060 students for doing such an excellent job of collecting data regardless of weather or health conditions. We'd also like to acknowledge the data was collected on Amduga, the Mi'kmaq name for Point Pleasant Park, which is the ancestral and unceded territory of Mi'kmaq.